Good afternoon, class. We're going to finish up acids and bases with our last concept of buffers. You may have heard of the word buffer before in terms of like a buffer zone or something that can absorb, like your bumper on your car is considered a buffer. And maybe you've heard of buffer zones around like freeways and things to kind of buffer the noise of the freeway to a housing area, if you will. So a chemical buffer is the same thing. It basically absorbs acid or base that you put in a solution so that the pH doesn't change very much. Okay, so I'm just going to fill in this little word concept. So it says a buffer is a solution whose pH changes very little when acid or base is added. A buffer, it's really important, this part, is a solution composed of approximately equal amounts of a weak acid, and the reason for that is it needs to be able to be in an equilibrium so it can shift to use up added acid or base. And we use that word conjugate base, and I'll kind of explain that more. The buffer resists the pH change because of the added base reacts with the weak acid and the added acid reacts with the weak base. So just a buffer definition, again, it is a solution that's made of a weak acid. So it's got to have two components. It's got to have a weak acid so that it can be in equilibrium. So that's kind of the big idea. And it has to have its conjugate base present. So we kind of talked about bases, and that's like what's left over after the hydrogen gets donated. So first and foremost, I just want to go through these and ask you a question on whether these are good sources. Can we build a buffer from these solutions? And so again, we're just asking ourselves the question, do we have a weak base and do we have a source of the conjugate base? Do we have a weak acid? So hydrochloric acid is a strong acid. We kind of hopefully know that. And so this one doesn't work because it's a strong acid. So this is a strong acid. And so what happens is it will not be able to establish an equilibrium. It's going to completely ionize. Okay. CH3COO, this one right here. This is a good option. So CH2CO3, if we go back to our list of strong acids and bases, there's somewhere here, I think we see that that's a weak acid. So we have that as a weak acid. And then when we think about, well, is this a source of its conjugate base? It turns out that NaHCO3, when you put it in solution, dissociates, the ions separate, okay? And this is, the conjugate of this when I let one of those hydrogens go. So this is a good source of being a buffer. It would be a good buffer system, okay? Sodium hydrogen carbonate and hydrogen carbonate. Okay, so I'm going to let you guys do the other two. Again, your question is it a weak acid and does it have a source of the conjugate base? And so when we would look at this particular equilibrium that I just wrote, I would write down C2H CO3 reacts with water and it's in an equilibrium. And then I get HCO3 minus and H3O plus. And so because I have both the acid and the conjugate base, it's in equilibrium. And so I have the ability at this point to absorb. If I add base, it's going to react with the acid that's present. And if I have, I should fix this. This should say H2O. If I have acid added to the system, it will react with the base. And if I add base to the system, it will react to the acid. So let me try to explain that to you here. This is a question that says, consider a buffer prepared from a weak acid, nitric acid, this hydrogen nitrite, and its conjugate base NO2. So again, you can see it's missing its hydrogen. So there's the acid and the base on the reactant side, and there's the base and the acid on the product side. They're in equilibrium. And to explain why we need both, right, we need the acid to react with added base, right? And we need the conjugate base to react with added acid. So it's necessary to have both species there so that basically they can respond if I add an acid or a base. So when we look at D, I have kind of down here written out the reaction, what it looks like up here, right? And then basically when the nitrite reacts with water, I get an acid and the hydroxide. So the way we can explain the response here is that if I add small amounts of acid, so I add acid to this situation, that acid is going to react with the conjugate base, and it's going to shift this reaction over to the reactant side. So that's going to increase the concentration of the HNO3 and decrease the concentration of the NO2. So the buffer is reacting to this added acid. And then when I add small amounts of base, I'm increasing this concentration. That base is going to react with this acid, and that's again going to shift this equilibrium over and increase the concentration of the NO2. So basically, a buffer has to have both of those components so it can absorb the acid or the base. If you have an unbuffered system, there is no acid to respond to the base and there's no base to respond to the acid, and so the pH will just dramatically change. And that is the last of our story about acids and bases. Hope you're having a great day. Thank you so much for listening.